Good morning, students. Good afternoon, students. It's wonderful to see you again. Today's topic is something that you already know, is kind of review and applications for two functions that are very simple. I'm referring to the linear function and the exponential function. Okay, so let's work first with the linear function and let's figure out how it works. Okay, so the first thing that we have is y equals mx plus b. Okay, I will work with a very simple function that is y equals 2x. Okay, so as you can see, 2 is the value for m, which is the slope, and v has a value of 0, is the y-intercept. The value is 0. Okay, so if you have x and y, 0, 1, 2, 3, 4, only five values from 0 to 4, and then y, the value for y will be 2 times the value of x. So 2 times 0 is 0. Here we have 2. 2 times 2 is 4. 2 times 3 is 6. And 2 times 4 is 8. Okay, so we know that that is a linear function. As you can see, we have always the same change. Okay, we have always the same change. As you can see, the change is 2 and then 2 and then 2 and then 2, which means we have a slope of 2. Okay, then we have the exponential function. We have the exponential. And it works something like this. Y equals 2 raised to the x power. Okay? And the form for this is y equals a times b raised to the x. Okay? So as you can see, the value for b is 2. The value for a is just 1. 1 times 2 is 2. Okay, so let's work a little bit with this one. We have x and y. Same values. We have 0, 1, 2, 3, and 4. Okay, so if you have the first one, 2 raised to the 0, there is a rule in math that every number raised to the 0 power is just 1. And then you have 2 raised to the 1 remains the same, 2. And then you have 2 raised to the second power is 2 times 2, this is 4, 4. And then you have y equals 2 raised to the third power is 2 times 2 times 2, and this is 8. And then you have y equals 2 to the fourth power is 2 times 2 times 2 times 2, and this is 16. Okay, this is 16. So in this case, as you can see, if you go in the first one from here to here, you are just adding 2 plus 2 plus 2 plus 2. In this case, you will find the same difference. Okay, so that means that it's linear. It is changing at the same rate. With the exponential function, works a little bit different. It works a little bit different, and if you go back, the difference is 8. If you go back, the difference is 4, is 2, and is 1. It is clearly that it's not linear. It's not changing at the same rate or speed. Okay, but as you can see, if you go from 16 to 8, they are related, because the 8, if you multiply times 2, you get 16. If you multiply times 2, the 1, you get 2. If you multiply times 2, the 2, you get 4. If you multiply times 2, the 4, you get 8. Okay, so in this case, we have additions and we have multiplications. Okay, and if we graph this, what can we find? Okay, so this is something that you already know. And the line will be in the first quadrant. Okay, so we have values from 0, 1, 2, 3, and 4. Okay, this is for the x-axis. And for the y-axis, we have values until 16. Okay, so let's do it in the best possible way. That means that I have 8 here, 0. I have 4 right here. I have 12 right here. Okay, so let's locate our values. That means that I have 2 right here, and I have 1 right here. Okay, so every value is there. Okay, so let's graph the linear, which is the easiest of all. Okay, it's a blue line, and we start right here in 0, 0, and we continue all the way to 4, 8. So this is my first graph. Okay, so we have 0, 0, and then I have 1, 2, and then I have 2 with 6. Hold on, the 6 is right here. Okay, I mean I have 2 with 4, and then I have 3 with 6. Okay, as you can see, I have a line right there. Okay, let's analyze now the exponential. Okay, with the exponential, I start in 0, 1. So I will start right here. Okay, and then 1, 2, I share the same point here. And then 2, 4, I share the same point again. And then 3, 8, here it starts to change, and then I have 4, 16. Okay, so as you can see, I have this form right here, and also I have this line right here. Okay, it should be a straight line. Okay. Okay, kids, so this is what I have for linear function and exponential function. Now, what is the application that we have for this? Okay, remember that in AQR at this moment we are learning about making money, decision making in finance. So you can learn how to work with your money or your resources. Okay, so today we're going to discuss an application for this. Okay. And one application is about the interest, okay? I will erase this. I will erase this, the interest, simple or compound. Okay, so we have two types. We have compounded interest, and we have the simple interest. Let's relate this one with an exponential model, and let's relate that with a linear model. Okay, let's say that I have an investment of $10,000. I will start with $10,000, and they offer me 44% annually. Okay, and let's see how it works in the linear model using the simple interest. Okay, in this case, I start with 10,000, and the bank offer me per year 4%. So the 4%, if you multiply 10,000 times 0.04, you get 400 pesos. I mean $400. I said pesos, it's dollars. Okay, and then you get this. And after the first year, you have this. But no matter what, you have to keep this money for 5 years. Okay, so let me write here, year, balance, interest, and the ending balance. Okay, so no matter what, the bank will pay you always the same amount of interest for the second year, the third year, the fourth year, and the last year. Okay, So if you go here, you have more money, but they continue to pay you the same. So you get in total now this, okay? So you start with this, and they pay you again this, even though you have more money, and you have this. You go to the 4th year with this money, but they continue giving you this. You start the 5th year with this, but again they will give you this, and you get $12,000. Okay, this is how it works with a linear model. Okay, now let's analyze how it works with exponential model. Exponential model, and we are going to continue with the same lines. Okay, so we have our exponential model right here, and we continue with this line. So we have years, the 1st, 2nd, 3rd, 4th, and 5th. Okay, and we start again with this money. We get $400, and then this is my ending balance. But now I am starting with this, and I need to get a new balance for this. So I have this times 0.04, and what do I get? Okay, so for that one I will get 416, so I have more interest now, 416. If I make the addition, I will get this. As you can see, in the 2nd year I have more money with this model. Okay, and then I will start the 3rd year like this. And what is the interest for that? Let's get it. 10,816 times 0.04. Let's say, and we have for that 432.64. Okay, 432.64. When you make the addition of this plus the interest earned, you have 11,248.6. Okay, then you start the 4th year with that money in your pocket, and it will gain more interest. Okay, so you will have 449.94, and the ending balance will be 11,698.4. Okay, then you go to 11, you continue with the same amount. Now the interest will be more, $467.94 to get this. Okay, now what is the trick? What is the trick? What is the difference? Okay, in the first model, they will give you the same amount every year, no matter that your balance is increasing. But with the exponential model, which is more like the compound interest, this is simple interest, this is compounded. That means that when you gain interest, they will take in consideration those interests to make you make more money after year. Okay, you may say, hey, mister, but this is not a considerable difference. In 5 years, the difference is just $166. And let me tell you that you are correct. But what about 30 years? Okay, what will happen in 30 years? Okay, let's build the functions. Now we have a function that is, let me check. I have a function that is 400, which is the interest, and x represents the year, 400x plus 10,000, which was your first amount that you deposit there. So if you evaluate for the 30th year, let's make this substitution, times 30 plus this. What did you get with this model? Okay, the projection is 22,000. Okay, in this they basically look similar, but now if we compare both for the coming years, then I have y equals, we have 10,000, and we multiply times the interest raised to the x power. Okay, 10,000 is the initial amount that we have, and 1.04 is, remember, if you multiply something times 1, you get the same, but we need to include in that the percentage, okay, which is 4%, and represented as decimal is 0.4. Okay, what about if I work with this linear function like this, raised to the power of 30? What do you get? You get a lot of money. Okay. Now the difference is more than 10,000. Okay, so you can see the exponential model for the compound interest is better than the linear model for the simple interest. Even though you start with the same amount of money, with the same interest rate, with the same amount of time. Okay, so this is the best option that you can have. Ok, chicos, en español rápidamente, lo primero que empecé a explicar es las funciones lineales y las funciones exponenciales. Cómo nosotros podemos tener la forma y después, mediante sustitución, ir agregando los valores a una tabla y con esos valores podemos graficar la tabla. Entonces, perdón, la función. Entonces, ya que vimos, según la gráfica, que la función exponencial tiende a crecer más rápido que la lineal, porque la lineal siempre se le está agregando lo mismo, como si fuera una suma. Pero la exponencial siempre está creciendo, digamos, mediante una multiplicación, digamos, por 2, y lo que te salga por 2, y lo que te salga por 2, y lo que te salga por 2, o por 3, o por 3, o por 3, o por 4, por 4, por 4. Eso depende de la base del exponente. Muy bien, trabajamos con uno muy fácil, 2 a la x, está bien fácil. 2 a la 0, 2 a la 1, 2 a la 2, 2 a la 3 y así sucesivamente. Sacamos rápidamente los valores. Pero también lo pueden hacer en su calculadora. La calculadora pues se van rapidito. Muy bien, ¿cuál es la aplicación? ¿Para qué me sirve esto? Tú puedes decir, bueno, pues algún día vas a tener un dinero extra que lo puedes invertir. Digamos $10,000, los puedes invertir en un modelo de interés simple, que es un modelo lineal, que va a crecer, pero va a crecer poco a poco y a la misma velocidad. Como te das cuenta, el banco siempre te está pagando 400, 400, 400, 400. Tu dinero está creciendo, pero siempre crece a la misma tasa. No va a irse más rápido. Lo que tú estás ganando, el banco no te lo está tomando en cuenta para que generes más intereses. Pero en un modelo exponencial, pues pasa el primer año, tienes este saldo, pero ahora ya no te van a pagar por los 10,000 que tienes al principio. Ahora te van a pagar por lo que tienes ahorita. Si te fijas, ahora hay más interés. Cada vez los intereses van subiendo, cada vez estás ganando más dinero. Pero te puedes decir, hey, profe, pero pues $166 no es nada. Voy y corto 7, no sé, 5 yardas o 4 y ya me los gano en un día. No tengo que esperar 5 años. Es cierto, tienes razón. $166 no es mucho dinero. Pero si hacemos proyecciones para 30 años, en un modelo lineal, pues tienes $22,000. Está bien, ganaste bastante dinero. Empezaste con 10, terminas con 22, ganaste $12,000. Pero en un modelo exponencial, como el que está aquí, empiezas con 10,000, pero terminas con 32,000. ¿Ok? Entonces el interés compuesto sirve. Y obviamente, entre más dinero le pones a tus cuentas, pues sales más rápido. ¿Ok? Thank you for your attention, kids. And muchas gracias por su atención.